Let's try to get this thing going live and in stereo. Hello, everyone. It's me, John Park, and welcome to John Park's workshop on this lovely Thursday. So today's topic is going to be synthesizers. Thank you, everyone, for coming out. We've got people over in the chat on Discord and YouTube. Very happy to see you. And I'm still freaked out by this camera thing I'm choosing to do here with these two. This one looks a little too much like that one, or that one. Let's do this. Let's go to the overhead on, whoops, this one. How about? Yeah, okay. So that's some of the stuff we're going to be talking about. I'm pointing over there. That's going to be the breadboarded version of our synthesizer, and then we're going to work on making a little tiny version. So this thing is super cool. Let me first of all show you the foundation of what we're talking about here, which is this little How about now? I wonder why that got muted. Oh, I know why. I think my when I switched to the screen capture here. Darn it. Let's see. Can you hear me now? I think you can. Sorry about that. I get to repeat myself a bunch. The screen share I had going on there. John, yeah, I know. I'm doing a lot of this lately. A lot of lip reading for everybody. Okay. Yeah, in case you care, I use Wirecast to broadcast. It's a switcher software, kind of like a TV broadcaster switcher. And I set up this screen share of the window you're seeing right here. And it came with its own audio, and it decided to automatically mute me. Let me click on this. I think that will prevent that from happening again. So, okay, backing up. So this is a synthesizer on a chip. This thing is very cool. I'm going to do a much better version of explaining it this time because I get to do it a second time. So this is a little ARM Cortex M0 chip, I believe that's right, that is the LPC810. It's a little 8-pin dip chip. And it is programmed with firmware by Jan Ostman, which emulates or models an analog synthesizer, a sort of traditional multi-voice 5-note paraphonic. You can do 5 notes at once. And I think they all go through the same pair of oscillators, but we'll talk more about that in a minute. And the connections to it are awesome. It basically has MIDI in, and it has audio out, and then you have ground and power. So you can do a very, very miniaturized version of this where you don't involve a microcontroller at all. And if you have a MIDI keyboard controller, I've probably got something around here. Oh, I've lost a couple MIDI controllers. Something like this. This is what was playing earlier. If I can unplug some stuff and show you. So this is a little sequencer drum pad knob kind of thing. That's what I was running through my modular synthesizer when we started. So this outputs either control voltage or MIDI or USB MIDI. So something like that, or my more old school MIDI keyboards There's MIDI is essentially like a serial protocol, and we'll talk more about that in another episode, I think. But point being, you can take this chip, and I've seen minimal versions of it made that are essentially a MIDI adapter plug, so something that plugs into that little 5-pin DIN. That's what's on the back of most keyboards, and then an output jack to audio, and you can make it so this chip is powered over MIDI. You press keys on a traditional keyboard or turn knobs, and this thing is going to do its analog synthesizing. So it's super cool. It's $20. It's ridiculous the things it can do. What I'm doing is another approach where you can drive it from a microcontroller. So we're going to do this with a Feather microcontroller. As you can see here, this one, let me move that for you. This is my prototyped version. If you were on Show and Tell last night, I showed that version of it. And we'll do a little quick demo with that for a couple things, and then we'll move on to trying to make a little miniature version on a Featherwing. So in this mode, you can just send MIDI commands again. So there's MIDI library for Arduino that I'm using, and I think we'll be doing something like that for CircuitPython soon. I can send out MIDI commands, which are very simple things like note on and tell it the pitch, essentially, like 24 is a C in the second octave. The velocity with which you've hit the key, so these things can be velocity sensitive, so 64 would be kind of a medium hit, 127 would be full-blown kind of hit. And what MIDI channel this thing reads on MIDI channel 1. And then we can tell it note off. I've lifted my finger off. And all sorts of parameters. There are 19 parameters on this chip that are controllable with essentially knobs or change commands, also called control change, continuous control. But a CC in MIDI is usually what things like knobs and pedals and other more potentiometer-like sweeping range kinds of things can send. So this can, and if you look at the page here again, this can take in different CC values. So for example, if we give it the CC command number 74, that is going to tell it how to adjust the filter's cutoff. So filter changes the amount of harmonics that you hear above the root of a note. So I'll have this thing mostly in sawtooth mode. So a sawtooth wave has like a lot of harmonics to it. It's very buzzy. And as you change a filter, you can cut off it's a low pass filter, so you can cut off the higher frequencies and get these kind of not quite flangey sounding kind of effects. So it's pretty cool. In fact, let me see. Yeah, we'll do that. We'll demo that. So these are the different MIDI CCs that are available on this little tiny chip. You can change these two, which are related to filter cutoff and resonance, which is like a little boost in the frequency right at the cutoff, gives you kind of ringing sounds sometimes. The filter has 4 parameters for how it comes in for attack, decay, sustain, and release. And then jumping down, so does the main oscillator. So this is when you hit a key, does it sound percussive or does it ease in? How quickly does it come down to its sort of moderate level, and then does it fade off when you release the key, or does it abruptly stop? So ADSR, we have 2 sets of those. And then there are what shape of waveform you're using, waveform wrap, which I think I don't understand fully, so I don't know what that term means, and I haven't heard much of a discernible difference, but there's a lot of variables that I'm playing with. I think one time I did, but I don't know what my other variables were. The range, which I believe is the there's 2 oscillators that can be just perfectly in sync, or you can move the second oscillator out of sync. I believe that's what that is. Detune may be that too. We could get a lesson in MIDI here today, because I think there's some people in chat that are more familiar with some of these synthesizer terms than I am. Master volume, and then there's a low frequency oscillator, which when you have the audible sound like me, then there's like wah, wah, wah that can alter the sort of primary oscillator in this. So anyway, those are all kind of what the knobs do on a traditional 1980s paraphonic synthesizer. Yeah, John, 2 to ADSRs, it's polyphonic or paraphonic. I think it means there's not a separate VCO per note, but you can play 5 notes at once, and they're using the one VCO, or the pair of VCOs rather. And anyway, let's get to it. Let me just check my chat over here. Yeah, DSP1. Hey, it's Old Crow. Hey, Old Crow is a Jan Osman code project. Wrap is probably waveform skew warp function. I'm so glad Old Crow is here. He's a real absolute master and expert in synthesis. So you can help correct me as we go here today. So let's see. What do I want to do? I want to, before I forget, take care of some quick business, which is today's coupon code. So thank you for tuning in to John Park's workshop. And somewhat predictably, today's coupon code is Synths, which is not easy to pronounce. Synths. Synths. S-Y-N-T-H-S. That'll get you 10% off in the Adafruit store until midnight tonight. I don't know who's midnight, probably Eastern Standard. So anything except for subscriptions and gift certificates and software if we sell it, but we don't currently, you can put your whole cart together and get 10% off with that coupon code today. Once again, the coupon code today is Synths. All right, jump off of that. So what I will do now is let's head over to the workshop cam. And let me put the down shooter in the corner there. And I'm gonna, as you notice, it's kind of windy today. I've got the workshop door open and I've got a diffuser here for light that is flopping around. So I'm trying to clamp it to a sandbag. That's my cheat sheet for the different parameters and what their CC numbers are and what I've got them assigned to. So I've got a little amp here. I'm going to plug into, let me zoom in so you can see. And sorry, before I forget, I need to plug in my camera switcher so that I don't have to walk around here every time. Ooh, the camera switcher cord is very tight. It must have gotten pulled on something. All right, so let's run back over here and let's see if I can swap cameras. We want that one to be big. Wrong one. I always, oh, this button's stuck. There we go. The physical button was stuck there. Okay, so I'm going to take this, take a second to explain what we've got going on with this chip. Let me go something to point with. So the chip, as you were seeing earlier, is, can it focus here? I should probably use the other camera, but nope. Okay, so there's the chip. I've got a feather here and a couple things going on. I'm providing power and ground to the chip. There's a little anti-aliasing circuit with like a RC resistor and capacitor circuit to smooth out the output before it goes to this little 3.5 millimeter jack. This is actually a breadboard-friendly headphone jack in the Adafruit store, but you can use it with any TRS wire. This is mono, but happen to have TRS going out, so I've tied the left and right channels together. Ground goes to sleeve. What else? And then you'll see here I've got this trellis. We're going to talk about that more in a little bit, and I've also got a knob that I've put through this piece of board. So let's plug it in and listen to, and I'll show you the code in a second. What I've got on here right now is actually going to ignore all my inputs, and this is, get this amp over here, that'll help. This is going to play 2 notes, I think a C and a G. So I've just programmed a little sample Arduino software here that will play those 2 notes and hold them, and then it's going to sweep through the filter, I believe, and then while that's up, it'll sweep through the filter resonance. So first cut off, then the resonance, and then I think I'm doing the detune maybe? Can't remember. So let's plug it in, listen, and then we can take a look at the code. So I need to power my feather on USB. If that's the code that's on here, that'd be great, because I think that is. Yes, all right. That's the resonance. with the LFO. All right, and it's just going to repeat that. So let me unplug that, and I'll show you what this code looks like, because it's really... Oh, I got to duck under this. That route is cut off today. So let's hop over to that. And let me move my Arduino window over here a little bit. So that's the wrong one. Let's make a new one. Sorry about that. Screen capture of... So rather than doing like a general monitor capture where my cursor always ends up in the wrong spot and I think it's laggy, I'm doing adding an actual application window as a source, but I forgot to add. It's per window inside of an application, so I got to pick the Arduino application and then the separate window for the piece of code I want to show you. I think actually Atom works better for this, but too late. All right, so Synth's parameter demo. Yeah, this is it. OK and OK. And can we, let's see. There it is. Get that moved over. And then find it in real life and try to scale it up. And this is always the... Oh, yeah, that helps. That helps make it look bigger. Come over just a bit. OK, so this is not elegant code by any means, but this is what I'm using right now. So I am including the MIDI library because this chip, the easiest way to talk to it is to send MIDI commands, which makes this thing really nice and simple to work with. So I'm including the MIDI library. I'm creating a little MIDI instance. In some parts of my code, I was doing things where I might want to output something other than channel 1, so I had a variable in here. I can't remember if I'm using that for real later. And then I'm blinking the LED, so I give that a name. And then in the setup, I'm creating a serial window so I can look at the output, or creating a serial instance, setting my LED to be an output so it can light up, and then I'm beginning MIDI on channel 1. You can actually begin MIDI on channel Omni, which allows it to look for anything as far as inputs go, I think not on outputs. We're not inputting into MIDI, so I don't, that doesn't matter actually. These are the parameters that I mentioned before, so I am setting them. I think the chip may remember what you set last when you pull power. Does that sound plausible to people? Because I feel like that's happened to me. Oh, John asked, what feather is that? That one is a Feather M0 Express. That's right, Nate. And I've been running this on both a Feather M0 and a Feather M0 Express. You could run it on probably any Feather. 32U4 for sure. If you're trying to do MIDI stuff, the 32U4 and the M0 are really good, but I'm not inputting MIDI onto the board. I'm not outputting USB MIDI, so that kind of is not an issue right now until this project grows. So here are me setting what I'm kind of considering my default values for all those parameters. So I've named them over here. So volume is this MIDI CC7, and I'm setting it at kind of full blown. I'm not sure if that's a good or a bad idea, but there it is. I was turning off the LFO just because it is that sort of changing sound, and with that changing while I'm trying to figure out what some of the other changes are, it's a bit much. So I've set that modulation to 0. The rate doesn't matter. That would be how fast it is if we heard any. You can pick different waveforms. This one, I think the values, anything from 0 to 63 is going to be a sine wave. I think. It said on one piece of documentation that it was a triangle wave, but I think it's a sine wave. And then 64 to 127 is a stop and hold for the LFO. The filter cutoff was what we listened to just now, sweeping through that where in the frequency band above the fundamental was it cutting stuff off. Resonance is how much it sort of peaks or emphasizes the harmonics right at that cutoff. And then I mentioned here's our attack, decay, sustain, release for the filter. Down here's attack, decay, sustain, release for the oscillator, detune. Here, range. Yes, I was calling range. I think it sounded like a 1-octave chorus when I set that to 12, but again, or 13 rather. Correct me if I'm wrong, anyone. Okay, so, and here's a little cheat sheet for myself. On the main waveform for the main oscillator, these values seem to be it. I haven't tried values in between. It may be that it just sticks with a triangle wave until you hit 25 and it sticks with a square-ish. There's like a real square, that pulse, but then there's a square with some slants in it that I don't know what those are called that are in opposite directions at 75 and 25, and then there's a saw wave, which is very harmonic. It's up and straight down, up and straight down. I think I have that set there. It's got the most harmonics in it. Okay, then in my loop, what am I doing? I'm reading MIDI. No, I was previously. I've taken that out, so right now I'm not reading MIDI because I don't have any MIDI plugged into this, but you can. So really all I'm doing is sending myself little messages. I'm playing a pair of notes right here. So a C and an E, actually. I think that's right. And then I'm sweeping through. So I created a little procedure down at the bottom here that's called sweep filter cutoff and sweep filter resonance and then sweep detune. And I might neaten those up so there's just some sweep thing that I can then give it 1 through 7 choices of what things to sweep for me. But if you look at those down here, this is what it looks like. So I've got the direction I want to sweep, so dialing the knob up or dialing the knob down, and then the rate at which, how fast is it going to turn that knob for me. And what happens in the loops of those is if the direction is meant to be up, we're just iterating this middle value, which is the control, the CC value, goes from 0 to 127, and then this is 127 down to 0 when I drop it. So that's kind of all that's going on that one. Let's listen to it and watch let's see, how are we doing on time? Nah, let's, oh yeah, you know what? I think I've got a long enough USB cable. Let me go grab a USB extension. I think we'll be able to watch the serial console while that plays, so you can sort of visualize. This would be kind of fun stuff to plot on the graph too. So let's see. We'll plug this into here, and let's steal this MIDI cable to go. Sometimes MIDI cables don't like to be this long. Sometimes it works out okay. So we should be able to hear this. Wow. I think it's very loud. Sorry. Let me try to open up a serial port. Ooh, I wonder which one it is. Okay, it's this one. So for you to see that, I get to make another screen cap. Sorry, Wirecast is getting impatient with me making this many windows, so it's taking it quite a while. Just don't crash, whatever you do. Thank you. It's dicey. You're living on the edge with this. Okay, so select a new Arduino. Does the serial port show up? Yeah. Okay. Almost there. Let me just pop that onto the screen for you. Okay. So let me turn this up and you can see those values and what they correspond to. So that's kind of cool. That's when those two oscillators go out of sync with each other, which makes nice, fun, warbly sounds. Okay, let me unplug that then. And, oh, you know what? While I've got it plugged in, I'm now going to upload this Trellis code to it. So let me switch over to this one for you. That's the one that I prepared in advance. And I'm just going to push that to the board. So what this one does is similar to what we have going on with the other one, except now I'm also instantiating an Adafruit Trellis object, which, if you're not familiar with the Trellis is super convenient for these kinds of projects. It's a little 16 button and LED PCB. I've got a bunch of LEDs ready to go in one, and these are these nice squishy soft buttons that diffuse the light through. See, I'm losing LEDs, so that you can see which button you've hit or which button you ought to hit if you're doing something that's guiding you, or if you're building sequencers, you can have your steps show up on here. So there's a lot of cool things we can do with that board. And what I'm doing right now, if we look at the code, is I'm doing kind of the standard Trellis stuff, which scans to check for any buttons being pressed. I have it lighting up whichever one I press. This is fairly standard, but you can do other things with it. And then I've set up some different modes. So I've got these, I'm calling them scale major, minor, Dorian, Mixolydian, and harmonic minor. And so what these are is, major scale is going to be all the white notes on the piano. Minor scale is going to choose a few of those black notes, and so on. So these are different scales. And by mapping essentially 2 octaves of one of these scales to the 16 buttons on the Trellis, it makes it harder to play stuff that sounds bad. If you just do a chromatic scale where every white and black key on the piano, for lack of a better way to describe it, every half step is on there, you kind of have to know what you're doing, and it's a bizarre form factor. I'm not a keyboardist, and this thing doesn't look like a keyboard. So I'm defining some scales here that we're going to put onto the controls. And then I have one potentiometer right now, so I'm setting up an analog read on that one potentiometer. I'm calling it CCN. I'm planning on calling these 0 through 6, so I can have 6 potentiometers eventually. And what those will do is we'll be able to change our values on some of these parameters, like the low frequency oscillator or the detune. We're going to have knobs for those, ADSR. And then in the setup here, I'm creating a serial port, so again, I can read messages. I am then lighting up the Trellis once and then turning them off. So this is kind of a little sweep thing from the Trellis demo code. It just looks cool. And I'm beginning MIDI, so I'll be able to use MIDI commands. And then I'm using, from the MIDI callback demo sketch, I believe it is, there's this method of using these, what to do when it receives a note on, a note off, and a control change. I actually don't think I need these because, again, I'm not reading MIDI, but I had left these in there from when this was a more complicated bit of code a couple days ago. Again, I'm setting all these parameters once in the setup, and then we can go and change them later with a knob if we want. So then this is the main loop. So I'm reading for MIDI. Actually, I can probably turn that off because I'm not actually plugging MIDI into this. Then here's my Trellis MIDI keyboard. This is, I don't know why, but there's this 30 millisecond delay that must be here with Trellis, and without it, it does not work. That was actually causing me some problems when I was trying to do both read MIDI and the Trellis at the same time, so it might be worth figuring out a way to avoid this or code around it. So then I'm checking my little potentiometer. I'm printing out the value of that, and what I'm sending out right now is the filter cutoff. So my knob will be for the filter cutoff, and that's that CC74. Then we have in Trellis, again, some pretty standard Trellis code. I have momentary mode, which is press and release, or we have latching mode, which I'm not using in this right now, which will hold something until you press it a second time. Actually, we could switch to that and try that too. So main thing we'll focus on is this momentary mode. And what's happening here is we're reading the switches. We check all 16 of those, 0 through 15. If something gets pressed, we turn on to LED. And then this is the only thing that really matters to the synthesizer chip, which is we're sending the note on of whichever button that is. So if I press button 0, it's going to pick the first thing in the index of my scale harmonic minor. That's the one I'm choosing right now. It's going to hit a full velocity on it, and it's going out over the out channel, which is 1. Then it lights the light, and it prints out some info for me. When I release, oh, am I not doing right display here? I might not be. I don't think that's actually going to light. We'll try it, though. I've been noodling with this code. Interesting side story, and we'll get to this in a minute. I was hearing some hum and buzz with this project when I had it on the breadboard, which is what we'll see now, when I pressed buttons or when I left LEDs lit on. And this is because of audio being very... oh, someone's saying the 30 millisecond wait has to do with the HT16K33 chip itself, register buffer collision avoidance. Oh, interesting. Thank you, Summersoft. I was hearing hum and buzz just because audio circuits are tricky, and I had ground loops and other problems going on the breadboard. So we'll talk about how I avoided those when I got to the putting this on an actual feather wing, which I'm going to do a little bit baking style for you, a little cooking show style for you, because I soldered it like a half hour ago, just finished it, but I made movies of that, so we'll look at those. All right, enough talk. Did I upload this? I did. So let's try this out. Let's switch cameras over here and go to that one and this ones. All right. I may need to turn the volume down on it. Let's see. Are you working? Nope. Turn up. Okay, so you might hear, here's the, sorry, there's my head in the way. Here's the, hear that? That's the blue LED. Watch when I do a red one. Different. So I think some of that noise is got to do with ground loops I have on here. But here, let's ignore that for a moment. Ooh, let me turn that down. So here's my harmonic minor scale. And then an octave lower. Oh, higher. So that's how I've set up those 2 sets of 8 buttons to be sort of nicely playable. And then I was just goofing around with kind of the weird, how would you do chords and play stuff on here yesterday. Okay, I'm not going to win awards for that, but that's the basics of how to play that with that scale on there. Now let's also check out our filter sweep using this potentiometer knob. Sounds like I have some oscillator or detune or something that's causing that. All right, so you get the basic idea of that. Now, I just want to switch this. I'm going to move this over here. I'm going to switch on my iPad so I can stay over here at the workbench and watch the chat for a minute while we talk about moving this thing onto a proto board, a Featherwing proto board. All right, I'll leave that there. And excuse me while I fire up. I get that. Oh, good. The camera switcher is activated. Sure, that's a reasonable thing to. Hi, I'm cut off by my. All right, let me just set this. We're doing good on time. I think we're gonna just nail this. Let's go to, where's the Discord? Come here, Discord. There you are. And it popped up my YouTube, but I do have to find the current video for that. So let's turn the volume all the way down. Yeah, mute. Good. Oh, look. There's our. Good. I'm talking to myself there. We'll pause that. And just got to find the chat. Not top chat, but live chat. They're really pushing that, aren't they? All right. So, good. All right, great. We're good. So looking here, oh, that's cheating. Don't look at that yet. let's see. So what I want to do with this is move it to a Featherwing Proto. So there's a feather. And I can get a little closer up with this camera. I don't usually use the little onboard light. I don't even know where the heck the switch is for it, but I think I will. Where is that light? Someone who uses this hovercam light, tell me. I don't know where the heck that is. Maybe it's just the software. Oh, there it is. How's that? Oh, that's terrible. Okay. Well, I'm just going to fix the white balance a little because that bugs me when it's blue. And let's fix the focus. Okay, let's make that the big view then. How about? There you go, there and there. Okay, so there's our feather. And then let's, so the idea here is to take a Featherwing Proto. Let me grab one of those. And there's a little IC socket that we'll use. Featherwing, where are you? Proto. Oh, you know what? I might be out of those, but I do have the doubler, which is a similar thing. Okay. I debated putting this on a doubler so that I could then later put a MIDI in and out on it, and maybe that'll happen some other time. So imagine just that part of that, right? So on this Feather Proto, I want to put my little IC. These legs are bent right now, so I don't want to go in, but pretend that got in there straight. And I'm going to unplug the breadboard version. And then essentially this circuit here that I mentioned, so the two capacitors and the resistor, got my little headphone jack out. And then I'll need inputs for the Trellis, which go into, the SCL and SDA on the Feather. So those inputs are there. And here is, let's see, do I have one more of those headphone outs? No, I don't. Okay, so let's steal it off of this board for a second. So as I started planning this thing out, at first I was looking at stuff like, can I put it right onto the Feather Proto area itself, which would be kind of slick, but there's basically no room here, especially on this Express, because of the flash RAM, I think, and the little dot star or NeoPixel, I forget. We don't have a lot of room. On a regular, let's see, is this one a M0? Yeah, here's an M0, not Express. We do have a decent amount of space, and I've managed to fit some similarly sized circuits on here before, but this one, just not enough space because we really eat up a ton with that headphone jack, and I thought that was cool to put that there. So let's now switch over to the baking show part of this. This is the first time I've done this way, but I figured, you know what, if I could turn on my video camera and let me make myself go off to the side here. Audio thing again. Yeah, it is. All right, can you hear me now? Yeah, okay. So every time I switch to one of these, because of their audio settings, these are movies. This is a QuickTime movie. It wants to steal my mic. So remind me of that if I don't. So now I'm just going to find that movie, which is here. And I'm just going to scrub through these so you can see what's going on. So there's the IC going on. I'm going to take a little blue tack, flip it over, solder it. I can move pretty quickly through that. Solder, solder, solder. Now, since none of these are connected rows like on a breadboard, what you have to do is either take up a little bit more space and run wires between things, or in a lot of cases what you're going to see I did was just shove a bunch of things through a single hole so they get soldered together, or bend wires over to reach the next whole over. In fact, let me... Let's switch to... Should I switch to fritzing? I want to show you this diagram. I'm going to make one more screen capture window here for you of the circuit that we're using. I wonder if you can hear me when that's beach balling and trying to open this window, because, yeah, I think it can. It just stops updating the... All right, so window... What window am I trying to open? Let's open up the Finder over here. Yeah, we'll do a screen share, actually. Let's do the monitor. Select window monitor. That one over there. And select screen region. Sure, that should do it. Okay, and okay. So you should just see my downloads folder of my Finder show up here in a second. All right, and if we, I think it's just on the desktop. Let's look this way. Aha. So, yeah, this is pretty much what we're making. So you can see I've got kind of two versions of this here. One is I can kind of see what's going on because I put it on a little white breadboard. This is what it's going to look like on the Featherwing Proto. So this is a built-in fritzing. And so you remember I talked about having the hum and the buzz. So the hum and buzz, I was talking to my good friend Todd Kurt about this and theories on, so I knew my hum and buzz was coming from the LEDs being scanned on the trellis. I could hear that. If I unplugged the trellis, that went away. Or if I lit a lot of buttons, a lot of lights on the trellis, I could hear that hum. And he said, well, I think it sounds like you've probably got ground loops going on. And so if you look at the way I have this on my breadboard, move this over. You can see I'm kind of doing the typical breadboard thing, which is I'm running 3 volts out from the feather to the rail, and then the rail to the chip, and then the other 2 power inputs on the chip from the other rail, and this is running around here, and I've got ground coming in at a bunch of different places. He said you want to kind of have a star single point to many pattern rather than this kind of one-to-one thing. So that made sense, and it also actually works better with trying to build this onto this board. So that's why you can see this is ground here. And what I'm doing, I actually do a bunch of this under the board, but I'm running ground to the one leg of the synth chip that needs ground, and then that ground wire is actually just bent over to the next hole, which is going into this capacitor. The 2 capacitors have a shared leg here. They're also actually sharing with this resistor, and then that ground continues on and goes to the sleeve of the headphone out or the audio out. So this is a much less likely to produce the hum from what I had before. And then same with power. You can see instead of running power to here and then a straight power to there, a straight power to there, I'm just kind of making one long series of these guys instead of lots of different sources. So that's the idea behind it. I know you're going to lose my audio for a second here when I switch to this, but I'll fix it. Okay, yeah, fixed. So here is movie 2. So let's switch over to that one. All right, so what did I do here? This is some of that. So you can see I've got one small bent lead that I'm using to connect the first power pin of the chip to the power rail on the Proto, which is coming from the 3.3 volt of the feather. Making little wires, plugging that in, skip ahead and solder it. Now I'm coming up with the wire that's going to connect that power pin to the other 2 power pins on the chip just on the bottom side of the board here. So I get the insulation off just the right amount so I can run that across. I've got some blue tack on there so that I can leave it with only owning 2 arms. Solder that up, switch it over, yay. Okay, so now here I've got a resistor. I put this under the bottom side of the board too, and I run it from that third leg of the chip over to a hole that's going to be shared by the two capacitors that also touch that resistor. Clip some stuff, and now I noodle around with these ideas about where the capacitor legs need to go. I say, you know what, let me go ahead and put the headphone jack in because I know where that's going. Some of this is, I don't want to put you kind of want to solder from the inside out when you're in a crammed space like this, so ideally you arrange it that way so you're not fighting stuff. I put the legs, the header pins on last. So there I'm cramming capacitors into the same leg. Let's skip ahead. Oh, now I'm running the ground over to where the ground goes. This is the TX, so the feather will be able to transmit to the chip. So the TX out of the feather wing and the feather going to the MIDI in on the chip. DSP1G1, DSPG1. And let's see, more of that. There's ground running all the way over to the headphone jack, and then the ring of the capacitor to the headphone jack, or the negative side of the capacitor to the headphone jack. And solder all those things. Next is this one here, which is, I believe that one. Okay. Is that the one we just did? No. Okay. So here I don't know if I just skipped ahead, but no, I guess I'd got everything in. Now I'm putting legs on. Go faster than that. Putting header pins. Good. Next, you are this guy here. Why does it keep opening the same one? Did I skip one? No. Okay. So here's the chip getting ready to go on. Now, one thing I didn't record is I checked continuity with a multimeter everywhere to make sure that before I put the chip in here and blow something up, and I only have one of them, I checked to make sure everything I had soldered in was correct, which it was. Yay. And then you can set the chip into the little IC. Yay. All right. This is getting exciting. Then what happened? I don't even remember. Let's see. This is movie 10. It's not the 10th movie. That's just its name. Now I am realizing that I didn't connect the two left and right sides of the headphone jack, so I do that. Wedge that in with some blue tack. It's actually gray tack. That's weird. Solder, solder. Looks like a guy fell from a great height and splatted. Okay. And what's this one? This next one is number 11. And okay, so now I realize I need a place to plug in power for the trellis. And by the way, I've tested it at this point, just the sweeping parameter thing. That all worked and sounded great. So now I moved on to let's put the trellis in here. And you can see I'm adding some female headers on the inner row of the proto board so that I can just plug the trellis into those without doing something so permanent in case I need to continue filtering it, like put capacitors across or something in case there was noise. So I'll solder in these headers. This one was funny. So you can see right here, I don't know how well you can see it, but I've got this one wire that I wired on the top of the board, which probably shouldn't have because I wasn't thinking ahead. So that's the TX line going out to the MIDI in on the chip. So I needed to trim one leg off, and then I had to actually go find a needle file, and I think maybe I did that on camera. Let's find, yeah, it should be this one. And cut out a groove so that that one would fit. So backing up here, you can see the desk is getting messier. There I am, selecting a needle file. It's good to have a little jeweler's set of needle files. And then zip, 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 zip. Fix that up a little more. And you can see right there, you can see it. I've shaved away like a little wire diameter sized thing so that I don't have to reroute that green wire. And then I solder in that female header pin set. And good to go. Oh, okay, so let's move over then to the downshooter and look at And then we get to listen to this version. So there it is. And like I said, I've only got one chip, so I now need to steal that off of here and put it on here. You can use, if you can get in there, you can use like a IC extractor. I'm actually going to use, to get that out, because you don't really want to bend these pins a lot, I have these tweezers that have this nice 45-ish degree angle bend, and I can go and get this under here and just lift you up nicely, and there we go. And then you can grab it with the tweezers if you like. Get that out of there. And now I'm done with that circuit. So putting this in, I want to look for the little indicator, the little dot, and the cutout here, and that matches the same thing on my IC. And you know what, let me pull a little portable light out so you can see that better. Now we're talking. So this will just, whoop, my light just fell over. It's kind of top heavy. It uses a giant Sony camcorder battery, or Canon, I forget which. Stay. I need a tiny sandbag for that. It's on this little tripod. So this will just go in like so, and it's good to go. So there we have, you can see I put a little indicator here of ground just because it's not easy to see it from the top of the board. And I just happen to remember, if I had some nice red paint, I'd put it over here on power. But I know that that's where my Trellis power is going to come from. So this is this neat little synthesizer package on a Feather Proto wing. Feather Wing Proto. So now I'm going to put it on this board, which I think is the one I have currently programmed with the Trellis software, but if not, we'll update that. And now let's switch to this bigger camera as we steal this trellis. Actually, I can leave it on here. I happen to screw the trellis onto this piece of wood just to keep it from flopping around for now. And I intend, once I get sort of the functionality totally, not totally, but largely determined on this, I'm gonna, my light there, make an enclosure of some kind that'll support the 6 buttons and the trellis. But I have a surprise in store about the trellis too. So now I'm taking that trellis off of the old board, and let's see, can you see that? Let's put that there. So this will go power and ground here, and then I just happen to know I have this set up with SCL SDA right there. And these are just some jumpers that I plugged on. I happen to have like a 3-position header, so I just didn't put a wire in the middle. Oops, sorry, you can't see that. In the middle, so that I could plug that in for power and ground with the spacing that I know you plug into on these boards. You can also, if you see, this is also kind of nice because you can put it diagonally in a breadboard. You can't put it this way because it's kind of 3 rows wide, but if you go diagonally, it'll fit. Okay, so making sure I got ground to ground. Let's plug in the amp. Does this reach? It does. It just reaches. Look at that, no hum or buzz. You will hear a helicopter go by. It's a good sign. This does not have power yet, though, so I shouldn't get too cocky. And now we should see this light. Yes, I saw that right. Let me turn this light off. That'll help. This doesn't do anything, how I'm wiggling like that. But you kind of want to add some tremolo or something with that. So yay! We've got a nice tiny little synthesizer. And let's talk about some plans then from here. I'm going to swap my cameras back out. Over that one there. And I'll turn this back on because I'm hoping the chat has thoughts and ideas. Let's see, at 140, Andy Calloway said sound is gone again, but I think that was, yeah, when I did that before. Okay. Oh, my Discord disconnected, and it's back. Quick to the chopper. They did find me. Oh my God, it's because of AdaVox 007. The helicopters are after me. So here's my thought with this is, I would actually like to take two trellises and connect them together. And these have, they're designed to do this. So the trellis, if you look on Adafruit, you'll see a couple of really cool, three really cool projects that use these that were kind of the originals, and then some others that have happened since just because it's a neat board for a lot of uses. But originally it was for a USB MIDI controller. So it would be a control surface for a digital audio workstation or a DAW or some other software synthesizer on a computer. So it uses a microcontroller that, like a 32U4 or M0 based microcontroller that can send out MIDI over USB. And then by soldering 4 or 8 of these together, you get the UNTZ, U-N-T-Z, or instrument. And then there's, I think, a 2 or a 4 version one. And then there's a little micro or mini UNTZ that the Ruiz brothers did that I think was a Bluetooth-enabled one that was just a single pad. So there's a lot of arrangements of these you can do for control surfaces. I think it would be kind of neat to do 2 up like that. Where'd my things go? Oh, and I'm preloaded with a bunch of red LEDs. I was actually debating not using these yesterday when I was having all that hum and buzz, and maybe using blue ones because they were not humming and buzzing as badly, or testing the white ones to see if that was better. But that hum and buzz is gone now, thanks to Todd Kurtz's suggestions of wiring this thing smarter. So I think an arrangement kind of like that. Move some stuff out of the way. And then 6 knobs. So I think I want to have 4 for ADSR, and maybe there'll be like a little cluster like this. LFO, filter, 1, 2, 3, 4, 5, 6. Oh, I'm out of, hey, why is that one so tall? Oh, that's a selector switch. So what, ADSR, filter, and LFO, something like that. Be kind of cool. And then if you look online, there's definitely, if you look up DSP G1, the name of this chip, you'll find some great projects, including one that had sort of a multiplexer or a port expander for analog, so that you could get like 12 knobs on a sort of standard 6 analog in type of microcontroller, and then like a bank select to go between even more knobs, or have those 12 knobs on there mean different things depending on the select. So that's why I got out this selector switch, and I was thinking about, I could do waveform selection with this maybe, since there's 4 or 5 waveforms. This is an 8-position switch, but maybe if you indicate nicely on the panel, you could have it be 5 waveforms or whatever it is, and ignore the blank stuff. Maybe use a couple of these, because there's some other things that you could just select more sort of binary or digitally versus these analog things. So I'm also thinking of using this little nice out instead of that, or connecting this to that, so that I could put this through a panel. These are these nice little 3.5 millimeter outs we have. And then from a software perspective, there's a lot you can do. And one of the reasons I was thinking of putting these together like this is this could make for a pretty cool step sequencer. So you could do maybe 4 voices of 8 steps, or you could call this a full 16 row and this a full 16 row, or something where it's very visual and apparent what you're doing for sequencing stuff together, kind of like that beat step that I was showing at the beginning of the show. So I think that's kind of a neat way to go with this. Other ideas are to create a software arpeggiator. So that's where if you hit one note, it will maybe climb up the octave and back, or do every note that you play in order, or whatever. There's a lot of cool sounds that you can get from an arpeggiator that would make it easy and satisfying to play this. Ooh, but not like that, sorry. Yeah. Oh, that knob doesn't do anything anymore. I forgot. Ooh. So that is the Feather Trellis DSP G1 synthesizer. It probably needs a more catchy name. But I'm going to start thinking about ideas for putting together an enclosure for it of some kind. Maybe some black metal and wood for old school 80s sort of synthesizer look. But if you have suggestions, I'll be hanging out in the chat. John K. asked, are each of the 5 channels volume controllable? No, I think there's just the one channel for everything, one volume for everything, unfortunately. And I'll hang out in the chats on YouTube until the video stream ends, and then everyone also on Discord if you want to hang out. And let's see, I will head back over to my machine for a second here to make sure I'm not forgetting any important business. So let me disconnect this. Whoa, sorry. Should have shut that off first. But I want to thank you all for coming out for the show today. I'm very excited about this synthesizer project and where these things are going. Hey, look, there's Discord. So come on over to Discord if you're in the YouTube chat and you want the fun to continue. Let me make that screen a little more useful. So let's see. Anything I'm forgetting? We got a coupon code. I'll put that back up there right now. If I can convince. There it is. Synths, SYNTHS, is our coupon code for the day, and that'll get you 10%. Oh, you lost my audio again, didn't you? What made that happen? Everybody type, we're famous on YouTube now. Whoa. All right. Yeah, YouTube, go over to Discord. Sorry, I just outed everyone on Discord for being on Discord. Isn't this public? Yeah. Cool. All right. Well, I had a ton of fun with this. You can tell I'm psyched. Hope we'll be doing more synth projects in the future. We have some ideas percolating around the M4 chips that are coming up because of some of their super duper excellent capabilities. So definitely stay tuned, and please hang out in the chat and give me your suggestions for stuff you'd like to see me do with this thing and going forward with some of these music-based projects. Thank you, everybody. This is John Park for Adafruit Industries, and you have just watched John Park's Workshop. Goodbye.